Let's take this new Siraya Tech Ppa-Gf glass fiber, 15% glass fiber filled material, test it, break it, see how it stacks up, and where it falls in the world of filaments. Where is it compared to nylon, PPS, all that? Stick around. We're going to get into it. We're going to figure out what this is. Hey everyone, I'm Scott, Edge of 3D, and welcome back. So, my friends over at Siraya Tech, Ben and Mark, they're killing it. They're killing it on these exotic filaments. What we used to think of as exotic filaments, these are becoming mainstream. But this newest stuff they sent me is a PPA glass fiber, which is, I'm going to butcher this, I do it all the time. Polythalamide. Polythalamide, I think, is how it's pronounced. I'll put the fancy word here. It'll be on the screen somewhere. PPA. What it is this is in between nylons, PAs, and polyphenylene sulfides, PPSs. This is PPA. PPS is, I used to keep something laying up here on my desk that I could, somebody called it a bar trick in one of the earlier videos. It's the metal sounding. It has the metallic sound to it. This is PPS. I haven't printed one of those in PPA yet, but I'll do that. So PPA, glass fiber. I've done tests on Siraya Tech's straight PPA without any film or any inclusions. I've done tests with their PPA CF carbon fiber with 15% carbon fiber in it, and their PPA CF core, which has carbon fiber particles or material in the core of the filament surrounded by regular material, and that's 25%. Links to those videos, I'll put them up here somewhere around so you can go back and check those out. Also, probably have links in the video description down below. PPA glass fiber is also 15% fiber, but it's glass fiber instead of carbon fiber. So I'm not going to get into is it bad for you to touch it and all that stuff. That's a debate that'll never be won. That's like talking politics. I don't do politics. I don't do whether or not this stuff is bad for me, because if we want to get into that, I still vape. I still drink coffee. You know, I do plenty of stuff that's bad for me. So, not going to get into that discussion. Let's jump over. I did the regular set of tests, and we're going to jump over and look at them. What that is the tensile test, which is this one here, where it's printed laying flat like that. It's 4 millimeters, 10 millimeters. I put it in the machine, pull it, break it. Then the layer adhesion, it's printed standing up like this, and this is printed with 5 walls, 40% infill, standing straight up, and then pull it and break it on the layer lines. Direct thread and heat set insert. So this is direct thread. So this piece is printed here with a 2.7 millimeter hole, and I take a 3 millimeter screw and I thread it in there 4 millimeters deep, and then same thing, pull it until it pulls out. And then the heat set's basically the same thing, but it's got a heat set in there. Thread into the heat set and pull it out. And then the Izod test, and that's this piece here where it sets up there in the hammer deal, and the hammer comes down and breaks it, and that records how much energy the hammer it takes away from the hammer breaking this piece. So shock test, Izod test. So we'll go over and look at those results right quick. So let's jump over here to the materials testing page. Link to this in the video description down below. The opening pages now on chart view, they're just getting too full to try to pick out a single material out of there. You can scroll through here and see where a material compares once you find it. So like this PPA glass fiber, this is the x-axis brake load. I believe it's down in this region here somewhere. Anyway, I do know one place where it's at the top. We'll get to that. So layer adhesion. Here we go. PPA glass fiber by Siraya Tech, 115 kilograms of force to pull out the direct thread screw where it's threaded directly into the plastic. So that's where it's the top at. We're going to jump over to comparison view here, and we're going to compare the PPAs that I've done. And you'll see that they're all annealed except for this one right here. And I've made the decision I'm not going to anneal these parts anymore for this set of tests, because this set of tests, it's just not making a big enough difference in the numbers between annealed and not annealed. So I'm going to save the annealing for the heat test. Tensile test, layer test, pull-out test, and Izod test. So we're going to grab the PPA glass fiber, carbon fiber core, carbon fiber, and PPA heated chamber, because I also did a set of tests on the PPA without the chamber heated. But all these have been done on the CD4 Max with the chamber actively heated at 65 degrees. So we'll start here with the x-axis brake load. PPA glass fiber, this is tensile, 385.63 kilograms. That's a very good number. Yield point is where it peaks out at before it breaks. Some materials will peak out and then continue to stretch while they go down in strength before they finally break. This is where it peaks out at 3.35, 3.37. That's for all the filled materials, which the difference between 3.5 and 3.7 is 0.02 of a millimeter. You can't even see that with the human eye. So 3.35, 3.37. The break point is where it breaks after it peaks out. And as you can see, 3.38, 3.39, 3.40. Basically, it broke where it finished stretching, or where it peaked out at. What you see here with the PPA, though, is it peaked out at 3.85 millimeters of pull, and it did not break until 5.17 millimeters, and that's on the annealed. If I go to the unannealed, or the stuff that wasn't printed in a heated chamber but was also annealed, it stretched a lot further. So anyway, we're talking about PPA glass fiber today. Layer adhesion, PPA glass fiber, 155.67. Very respectable numbers. 219.48 on the straight PPA with no inclusions. And so let's discuss that for a minute. When you include things like carbon fiber, glass fiber, anything other than a polymer or a modifier that blends with a polymer, those inclusions are also they help with some things, but they also can take away from other things. So it gives a place for the stuff to break. So this is 15% glass fiber. This obviously isn't. This is PETG here. But this material here is 15% glass fiber. So over this cross section here of 4 millimeters by 10 millimeters, so you've got a 40 millimeter cubed or 40 millimeter squared cross section there. Of that 40 millimeters, 15% of it is not polymer, it's glass fiber. So you have 15% less contact between the polymers. That's the best way I can describe it. So that's going to cause the numbers to go down a little bit in those. And that's where we're at with the layer adhesion. The numbers have gone down. Direct thread. PPA glass fiber did excellent on direct thread, 115.1 kilograms. That's a very respectable number. Heat set, just the opposite. It did the worst on the heat sets. It only added 35, 37 kilograms of force on the heat set. Still very good numbers. And then the Izod shock test, and that's this one here with the PPAs is backwards from what everything else is. Normally, as you add fibers and stuff to the material, the Izod shock test numbers go down. But for whatever reason with PPA, it's the opposite. 23.67, which is still a good number. And, if you jump over here in the chart view and we go down here, 23.67 is not clear at the bottom, but it's also, it's low. So what we have is a material that is stronger this way, this way. I haven't come up with a bending test yet to test how far it bends before it breaks. That's in the squirrel cage up here running around. How can I do that? Someday, maybe. So it's stronger like this. It's stronger like this. It's stronger like this, but it is more brittle. So it's not as strong with a shocking blow. So a bending moment, a strength like a frame here for a 3D sets car. You know, it's stronger this way for a frame, but a shock would cause it to break. I don't know how else to explain it. So that's it on the normal testing. Now, a new test that I developed in conjunction with Steve over at Steve Builds, because he's had some questions about it, and I'd been thinking about it and trying to come up with an idea, is how sharp a bend in a PTFE tube can material make before it breaks. And where that really comes into play is machines with AMS systems like that there, or like the CD there where it comes out of the drag chain and makes a sharp turn down into the tool head. How sharp a turn can this material go through before it starts breaking? And to come up with something to test that, I've come up with this test jig here, and it goes from 15 millimeters radius to 95 millimeters radius. And obviously I've already tested this, so I know where it's going to work at. But we'll start here at 45, and as you can see, no problems whatsoever. It goes right through the 45. 35, same thing. It's no problem whatsoever. And I make my samples about 1 meter long. That way, you know, because it might be a little flexible here, a little brittle here. So I want to pull it a long ways through there and make sure that if I'm telling you 35, that it'll go 35. Now, 25 millimeter radius. That's where we run into problems with this. And I'll get it up here by the mic. Hopefully you can hear it. There we go. It snapped in the tube. And it snapped again. And again. And then it goes for a ways. So 35, you're safe. 25, it may snap. And you can see there where there it snapped. It pulled quite a ways, but it still snapped. That's the purpose for the long samples. So 35 millimeter radius, you're good. 25 millimeter radius, you're going to have broken pieces and problems. So how do you measure that? I don't know. Print it out on a little circle and hold it up to your bends on your deal and see, you know, at what radius you're bending at. But that gives you an idea of how sharp you can bend it before it breaks. A couple other things to touch on real quick on this. They do recommend that you keep it dry, and I'll put a picture up here, but the spool, when it's new, it's got a little tag on there that says, basically says keep it dry. It's fine print. I can't even read it. I have to shoot a picture with my phone and blow it up. Old eyes. So where does this stack up in the world of PPAs, PPSs, and that? It's 15% glass fiber. At time of filming right now, it's $48.99 for a kilogram. Straight PPA at the time of filming is $51.99 per kilogram. Now this is Siraya Tech's pricing, and this is whether you buy it on Amazon or Siraya Tech's board. Same thing. It all comes from Amazon. They ship with Amazon, but Amazon fulfills their orders. But you can buy it direct, or you can buy it Amazon. It's coming from the same warehouse. PPA unfilled, $51.99 a kilogram, and these are full 1 kilogram rolls. PPA glass fiber, 15% fiber content, $48.99. PPA carbon fiber with also 15% carbon fiber, $59.49. And then PPA carbon fiber core, which has 25% carbon fiber, is $86.99 a kilogram. Now, for comparison, Polymaker. I don't have a PPA Polymaker, but I do have PPSs. That's the next step up. PPS glass fiber 20. There's a spool of it up there somewhere. I haven't tested it yet. That's on the list to do. It's a 20% glass fiber, $59.99 for 1/2 a kilogram. So let's call it $120 for a 1 kilogram roll, or for a kilogram of material. Their PPS carbon fiber 10, which is 10% carbon fiber, $70, $69.99. We're going to call it $70 again for a 1/2 a kilogram, and that makes it $140. Now, bamboo, right there. There's a bamboo behind me. They have PPA glass fiber. I won't be testing their PPA glass fiber unless they send it to me, because I'm not spending my money, your money, Siraya Tech's, or Polymakers on it unless enough people ask to have me test it, and then I'll buy it. Because right now, for a 3/4 of a kilogram roll, 750 gram roll, on sale is $119.99. So to compare kilograms to kilograms, that's $160 for a kilogram on sale. When the sale's over with, it goes back up to $149.99 for a 1/2 or 3/4 kilogram, which makes it $200 a kilogram. $48.99, $200 for Bamboo brand. Bamboo also does not, anywhere that I can find or AI can find, list what their percentage of filament fiber ratio, like 10%, 20%, 15%. They don't list it. I've looked all over their websites. I had a very powerful AI engine go and search, can't find it. And then, of course, their PPS carbon fiber, which comparing that to Polymakers, now they're about the same price per kilogram, because Polymakers carbon fiber, $70 for 1/2 kilogram, which makes it $140 a kilogram. Bamboo stuff is on sale for $103.99 right now, so around $135 on sale for theirs. So PPSs, they're comparable in pricing. Obviously, I have Polymaker's PPS because Polymaker provides me with the filament. Bamboo doesn't. If I want something from Bamboo, got to use money out of my pocket. So that's it. That's where the PPA glass fiber from Siraya Tech lands at. It's best price as far as dollars per kilogram. The fiber content, it adds stiffness to it, it adds cost to it, but it also makes it more brittle. Bamboo charges a premium for their stuff because it's ready to print. This is ready to print too. I mean, I printed my normal carabiner out of it, and look, there's no layer lines because this is printed laying like this, obviously in parts, but it's printed laying like this. There's supports that have to go under here. There's supports that have to go here, and that's why I print these, to see how easily the supports remove, which did just fine on this, to see how well it prints. There's your layer line surface. There's your top surface, as you can see. Beautiful. And then it printed on a carbon fiber build plate, and it picked up the carbon fiber beautifully. So there you go. That's my typical carabiner. Link to the carabiner in the video description down below if you want to print one of these for yourself. I give them away at events, and I use them for water bottles on my airline bags, my backpack that I take on the airplanes. So great material, zero issues with printing. I had no issues with nozzle clogging, anything else. And I used a 0.4 nozzle, which, you know, some people say, hey, you can't do that. Well, I did. It worked. I didn't have any partial nozzle clogs or any nozzle clogging. I mean, that's a pretty solid print there. Looks pretty good. 0.4 nozzle. Obviously a hardened steel nozzle, but still a 0.4 nozzle. No problems with the fibers clogging it up. So that's it for now. That's the PPA glass fiber from Siraya Tech. And I think in the grand scheme of things, if you're printing parts for your car and stuff like that, where it's going to be subjected to some heat, but you don't want to spend $150 on the next step up. PPA is definitely a good choice. Glass fiber brings the price down a little bit over carbon fiber. Strength-wise, it loses a little bit over the carbon fiber, but really, how much do you need? If your use case doesn't call for that little bit higher number, you still get the absolute beautiful print. You get the parts that look like almost like they're injection molded. Okay, it's hard to tell that that's 3D printed. So you can have that, you can have the strength, the price is affordable for that type of stuff, and it fits that middle ground between just regular filament for printing things like this and really high-end technical stuff. So PPA, glass fiber, Siraya Tech, 15% fiber, $48.99 a kilogram. Links in the video description down below. If you use my Amazon affiliate link, I get a little bit of kickback. If you buy it direct from Siraya Tech, I don't get a kickback, but it doesn't cost you any more either way, and they both come from Amazon. Your choice. Using my link helps me continue to build these tools and maintain this website and stuff like that. I appreciate each and every one of you that watch these videos all the way to the end. I talk way too long. I set out to make 10-minute videos. They wind up being 20 minutes because I like to hear myself. So, Siraya Tech, PPA glass fiber, thumbs up from me. I like this stuff. I'm going to continue to use it for different projects. In fact, all of these brackets for these tests here, I'm going to do in that because it's good and it's stiff. So I have a whole roll of it left to use, so I'm going to start printing off these brackets with it. Don't know which video is up next. I did get a roll of PC carbon fiber from a company called YX Polyer. Not polymer, Polyer. P-O-L-Y-E-R. I did just finish testing that, so that video will be up very soon. I've got PPS glass fiber, 20% from Polymaker up there that I need to test. Just finished printing some parts for some heat testing on some PETG, so who knows what'll be next. I'll get to something next. As always, thanks for sticking around. Thanks for watching all the way to the end. Hit that thumbs up if you like it. Thumbs down if you don't. Leave me a comment. Good, bad, indifferent. Doesn't matter. Drop a comment down below. Hit the bell icon if you want to be notified when I drop the next one. And as always, if you hit the subscribe, it helps with the algorithm. Gets this video out in front of more people. Gets a little bit more income so I can continue to build these testing tools and buy filament and test stuff. So thanks for watching. Stick around till the next one. Peace out.